Network address translation was developed as a short-term solution to stop the shortage of IPv4 addresses. The depletion of IPv4 addresses was inevitable. However, with the addition of NAT comes the ability to translate internal IP addresses into external ones, and external ones into internal ones. When it comes to NAT, there are 4 types of addresses: inside local, the local network device; inside global, the address of your router as seen by the outside network; outside global, the address of the destination router as seen from the inside network; and then outside local, the address of the destination device within the outside network. Now, there are 2 different types of configurations for NAT: static NAT and dynamic NAT. Static NAT is a one-to-one translation between a local address and a global address. Dynamic NAT uses a pool of public addresses on a first-come, first-served basis. There also must be enough public addresses available for the total number of sessions. Additional sessions will fail if there isn't another public address available. Dynamic NAT will be a many-to-many translation, where multiple global addresses are able to be translated to local addresses. The most common form of NAT is called Port Address Translation, or PAT. This is also called NAT overload, which has a many-to-one address mapping method. With PAT, multiple addresses can be mapped to one or fewer global addresses because each private address is tracked by a port number. This table can show you exactly how it works. With it, you can tell the NAT table will know exactly where to send the information. It is mapped so that those IP addresses that are sending the information to the server will be recognized based on the port. When the servers need a reply, the process of sending packets will be reversed. Next available port technology was created when an inside local IP will attempt to use the same port as another inside local IP address. PAT will attempt to assign the next available port from a port group. TCP and UDP both have more than 65,000 ports. In total, there are more than 130,000 ports available for PAT to use in this case. The good thing about NAT is that it conserves global IP addresses, increases network flexibility, provides consistent internal network addressing, and security. However, there are some drawbacks. For example, performance is degraded, end-to-end functionality is degraded, end-to-end IPv4 traceability is lost, tunneling becomes complicated, and initiating TCP connections will be disrupted from other networks. Let's look into NAT configurations by starting with static NAT. Static NAT is configured by mapping an inside local address and an inside global address. For example, let's say we had 192.168.10.254 as an inside local address, and then we had 209.165.201.5 as an inside global address. We would use this information to configure the command like this: IP, NAT, inside, source, static, followed by our inside local address and our inside global address. After that, you want to configure an inside interface and an outside interface. To do this, you would hop into the interfaces and use the respective IP NAT commands to define an inside or outside interface. If you want to see your IP NAT translations, use the Show IP NAT Translations command. Let's talk about dynamic NAT. This allows automatic mapping of inside local addresses to inside global addresses. The most important detail that you want to take away from this is that you need to define a pool of inside global addresses, meaning your router will need to represent more than one IP to provide for dynamic NAT. When configuring this, you need to identify a NAT pool using the IP NAT pool command. You can give it a name and then define the pool of inside global addresses. For this example, we're going to use the pool 209.165.200.226 to 209.165.200.240 with the net mask of 255.255.255.224. After that, you'll want to configure an access list to allow translations. For this example, we're going to permit addresses from the 192.168.0.0 network. Remember, this is done on a first-come, first-served basis. You can change whatever you'd like in this, including the wildcard mask, to allow a certain group of hosts. Once you've configured the access list, you'll want to plug it into the IP NAT command. This is called binding. Binding is when we bind a NAT pool to an access list. After that, all we have to do is assign our interfaces either as inside or outside NAT interfaces. You can do that with this command. If you want to configure PAT for a pool of IP addresses, you can refer to our steps on configuring Dynamic NAT. All you have to do is add overload to the end of this command. This will allow you to overload NAT. To configure PAT for a single global IP address, you'll want to follow these examples. The first step is defining an access list to define the IP addresses that can be represented with PAT. After that, you'll want to configure IP NAT like this. You'll use an interface here and define overload. Don't forget to specify the inside and outside NAT interfaces. If you want to verify PAT, you can use these commands to verify your results. Let's talk about port forwarding with Cisco iOS. For this, you'll want to establish a static translation between an inside local address with a local port and an inside global address with a global port. For example, if we're setting up this web server, anyone attempting to connect to 209.165.200.225 through port 8080 will end up being able to communicate with 192.168.10.254 through port 80. Don't forget that we need to configure our inside and outside NAT interfaces. Here are some commands you can use if you're trying to troubleshoot NAT. And that's it for this series. Just keep in mind that it's a crash course and we only covered what was necessary. If there's additional information that you need, check it out online or through NetAcad. I hope you enjoyed the series. It was a lot of fun to make, and I look forward to making the next one. Do check out the Windows one if you haven't checked it out. Until the next one.